All right, we are online right now.
I see. Okay. Good afternoon, everyone. My name is Haskuchi or Randia, whichever suits you the best. And here I am as a host of the podcast with me, Haskuchi, and we're my friend Andra as a guest here, and Adil as a uh, audience, maybe the speaker,
Not
the
taker, right?
writer, and yeah, not taker, basically. Yeah. In any way, in any case, welcome. And today is Andra's turn. So as you can see with the title, it's about electrolysis cell. It's about chemistry again, as expected as Andra, like he is a chemist through and through. So come on, Andra, tell us about this topic.
Okay, wait a minute. I mean, I'm gonna show
Share
the
screen.
show my side screens about electrolysis cell.
All right. Um, while waiting,
All right,
here we go. All right.
you can see it.
Can you see the screen here
Yeah, you can
right
see it.
now?
Yeah.
Right. So
Nice. Nice
now,
start.
okay,
Okay.
all right.
What
So
is?
electrolysis. In a couple of last weeks, we already learned about many things in case of electrochemistry series, and one of
Mm-hmm.
them is voltaic cell that we already set up. We already learned about how to
Mm-hmm.
calculate the fault. Yes, the fault about two compounds or electrodes in voltaic cell, and how to from the notation cell or cell notations about it in terms of voltaic cell. Now we face the electrolysis cell, and yeah, this is the periodic table of the elements. You see that
Mm-hmm.
usually we play about the group A. So group A is ranged from 1 to 8. You know, 1 means that it just contains 1 electrons, and the group 8 means that it contains 8 complete electrons. So every single compound or substance uh, wants to be a noble gas, like in the group 8A. This is the
Okay.
truth of the chemistry. Like this is the noble gas, where uh, the substance very very stable, man. Everybody
Mm-hmm.
wants to be like that, so everybody actually strives to become like that.
I see.
Yeah.
Helium, neon,
Now let me
orange.
review about the difference between the galvanic cell or voltaic cell and electrolytic cell or electrolysis. You see that in electro sorry in galvanic cell or voltaic cell, it converts chemical energy into electrical energy. Right, so for example, like the battery that I already taught you.
Mm-hmm.
When you use the battery, let alone your battery on your laptop. Okay, so it is actually the mixture of your chemical compounds, but it actually chef you around power. I mean, it chefs it power, and it will be released once you use it to be electrical, right. So in other words, it converts chemical to be electrical. So the reaction happens in the spontaneous. And then I will say that this kind of voltaic cell has negatively charged anodes and positively charged cathode. Sorry. So I could say that uh, you see in galvanic cell, anode anode is this negative,
Mm-hmm.
and cathode is the reverse. What is that plus, man? Now uh, I mean, you know, uh, you see that you should remember about the what is kependekan, man. I mean, like
Abbreviation.
That,
abbreviation,
yeah,
abbreviation.
abbreviation. It's
Um,
true. Mhm.
you see, in Indonesia, in high school, we can say kapan,
Kapan?
katode positif,
Another negative.
and anode negatif. Yeah, something like
Mm.
that. All right. This is for the galvanic or voltaic. Now we turn our side to electric cell or electrolysis. Now
Mm.
it is actually such a non-spontaneous cell reaction. Why? Because it converts the electrical, the electrical to be uh, chemical. All right,
Mm.
and it has positively charged anode. So we say that anode and cathode are the reverse of the voltaic cell. So anode contains what? Positive.
Positive and a cathode
That,
negative.
we may create the abbreviations about we may create the abbreviations such as kenapo, kenapo,
Kenapa?
kenapo, kenapo.
Kenapa?
Yeah,
Why?
yeah, because you see cathode negative
And another positive. Got
and
it.
another positive. Yes.
Hmm. Really nice abbreviation.
Yeah, it is derived from our Lord, Ren. You know, Miss Alexia.
Oh,
Oh,
you
oh,
should.
oh, oh,
Yeah.
man.
Okay. Got it. Got it. Our yeah, that's true.
Our beloved
I mean, is
listener.
it only for our teacher? I think it's more like.
I
I
mean,
think
my teacher
she.
also teach this, man.
Yeah, I think it's the same for our
For
like
every
for
All right,
almost.
next,
yeah,
we see that these are one of the electrolysis cells applications.
through.
So
Oh, I see. Mhm.
you may see that the electrolysis cell applications can be used for the hydrogens productions. All right, so you see that hydrogens contains H2,
Mhm.
and it is included in our water, as simple as like that.
Ah, yeah.
Hence,
Ah. Mhm.
what?
Yeah. No. 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 Go on. Go on.
All right, so you see that it's different with the spontaneous. When you use spontaneous, it's spontaneous, man. Like just for example, like what? I'm still thinking about it.
Well, like
Okay,
fall.
like you. Sorry, you know waterfall. So
Yeah.
waterfall,
Like.
just let the water flow
Hmm.
from up to down. But when you use pump, it works like from the lower elevations to the higher elevation, right?
True.
So it takes energy to what to bring the water up to the higher elevation. Same logical illustration for this electrolysis. So it's not spontaneous. It takes the energy to create the separation between what hydrogens and
Oxygen.
oxygen in this case,
Hmm.
in these hydrogen productions. Nah, that's why there is solar panel, there is wind turbines in order to create such energy. And yeah, you may see the hydrogen is released from the water.
Hmm. Got it.
All right, so another applications can be used for what? For electroplating here.
Oh.
Electroplating, yeah, current electroplating. So, you see, I mean, people actually dislike something that will crush or rusty. Yeah, rusty. See, like your spoon, your rounds, fine when you cook, it should not be rusted or stained. So we need to create or produce the stainless steel
Hmm.
to avoid this kind of rust, because when the steel is rusted, it can contaminate our cuisines or foods. Hence, you will be toxicated by it.
Yeah, tetanus.
Yeah. Maybe. I mean.
Tetanus.
Yeah, rusty steel is brittle and can contaminate.
Brittle.
Yeah, it's a bit brittle, so
What is
it's
Oh,
brittle, man? Wait, wait.
fragile,
Oh,
right. Oh,
fragile.
yeah,
and
yeah.
that's
It'll make the kopong.
yeah, and yeah, that's why the fragments of it is brittle and could contaminate foods and other stuff. If so, that's why. So I think rust is because of oxygen, right? As far as I know. So uh,
Yeah,
to
it's
remove.
the reaction between the steel and oxygen. Yeah, so that's why I mean there is the oxidation plays the role.
Yeah, yeah, the oxidation role. So electrolysis is probably just removing oxygen from the rust itself, or maybe I was wrong. I think it's kind of like that. To be fair.
Yeah, I mean, as far as I know, in this case, like you see that you just let's say you just produce a steel, and yeah, the way how to prevent it from the oxidation
Hmm.
oxygen contact. I mean, yeah, you need
Oh, I
to
see.
cut the steel with the laminar or uh,
Oh, some
the the metal that will not be rusted or stained.
laminate with something. Okay,
Yeah,
got
like
it, got it.
stang or what or another.
Hmm.
Andrea, just wondering, when you say that electrolysis isn't spontaneous, it means like if we want to, wait, 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 hold on. Electrolysis is basically we convert electrical energy to chemical energy, right? And what you mean by isn't spontaneous means that we have to generate the electrical energy. Is that what you mean, Andrea?
Yeah, that is what I mean. So
Oh, I
imagine
see, I
that
see.
you pump your water from the lower elevation to higher elevation. Does it take the energy or power? Yes, it does. So logically, it works like yeah, you pump the water from down to up. Okay, so uh, it not it no in nature is it will not happen. So it should be artificial,
Oh,
like
so
you give
that's
some
what you
energy to
mean.
that compounds to be reacted.
Wait, really isn't possible in nature? Like what? Seriously, not available in nature? Oh, that's kind of
Yeah, I mean,
cool.
so really it does available. What I mean, what is available is the voltaic cell instead, like your battery. Just look it from two electrodes, and your battery will work.
Yeah,
Like right?
kind of wondering, guys, when in electrical energy, is in nature only thunder that use electrical energy, or is there something else?
Sorry, what?
I mean, electrical energy is it's kind of like the transfer between electron, right?
Yeah,
From
yeah.
not from, for example, in thunder, you
Oh, thunder.
transfer,
Okay, okay.
yeah, in thunder you transfer
I,
electron from the cloud to the earth, basically. Is that
Yeah,
what
yeah.
I? And actually, there are many types, like static electricity. It's one of the kind of
yeah, I mean,
electricity.
thunder is naturally happen. Yeah, thunder
Natural.
naturally happens, man. Because I
Hmm.
mean, it happens when the higher potential to lower potential energy.
Hmm. So,
Oh,
Like
like,
I
yes.
imagine like cloud has a lot of electron, or maybe negatively charged, and then it transfer from cloud to the earth,
yeah, and
basically.
I guess aurora is magnetic energy or what? I kind of forgot.
Nah, I have no idea what.
No, no, actually, some say it's from the sun,
It is
but
the light.
I
Yeah,
don't
it is
really
the
know.
light problem, man.
Yeah, I think it's the.
Yeah,
So, yeah, electrolytic cell, as Andra described, feature non-spontaneous cell reaction. I think this is what I uh, gather from you, Andra. So, non-spontaneous cell is kind of like uh, it's storing energy, basically. It try to not storing energy. It's more
Yeah.
like
For example, like when you recharge your own phone, it is
yeah,
spontaneous because it requires energy from the lower to the upper higher potential energy.
yeah,
So it should be forced by the power. Hence,
mm,
oh,
when you when you want to use your own battery, it just flow as naturally happens because it's spontaneous, like
Mm.
from the higher elevations to the lower elevation or potential, eh, from the higher potential to the lower potential.
Oh,
Mm.
I see. I see.
Yeah,
I think I get. I think I
that's
get it.
mm.
Okay, you got it.
Yeah, I
Correct.
understood.
Yeah, that's why when someone wants to fool you, like, well, we can drive a car or we can ride a motorcycle by just adding up water. Well, I mean, yeah, that's possible, but actually, the energy that will take to ignite the hydrogen separation in your rounds chamber, vehicle chambers, is really tremendously high or huge.
Oh, huge. I see.
So I mean, the fuel from the water actually is ridiculous according to my own perception because it requires the higher energy compared to the fossil fuel like oil or something else.
Oh, I see. I see. I see.
Yes, hydrogen can drive you around motorcycle or car, but yeah, you know the energy that will take to ignite it is high. Now we already entered the reactions at anode for the electrolysis. You see that um, the oxidation, you know, do you still remember about the abbreviations of caret?
Uh, cathode, caret,
Oh, the
reduct. Oh
reduction.
yeah, yeah, reduction and oxidation. Yeah, remember. Cathode reduction. And like another oxidation, something like that.
Yeah, you are true.
Mm.
So basically, Carret's idea r- is relevant for both voltaic and electrolysis, different with the cathode based on the charge.
Mm.
Also, reductions and oxidations happens in the same way from both of these cells. So when it comes to oxidations, when it comes to cathodes, it's always reduction, and the other side when it comes to anode, it's always what oxidation.
Okay.
So in this case, we are going to talk about the reactions at anode first, and then answer the their friends. So next we see here oxidations. All right.
Mm-hmm.
So first, uh, in oxidation or in anode, we need to see the inert metal here, whether the inert metal that we use or the uh, I mean, is the electrode really uh, Ec, Au, or P,
Mm-hmm.
or platinums, aurum, or carbons? If the answer is no, then we should then uh, oxidize the electrodes. If the answer is yes, just take a look at the ion minus from
Mm-hmm.
the solution or the melt. When the so there's a question again. When we already took a look at it in the ion minus, is the ion minus residual oxidizing acid? If we answer yes, then just uh, put these reactions into the anode. When it comes to no, then we should take a look next. You see, if the answer is no, then there is a question again. Is the ion minus hydroxide? If the
Mm-hmm.
answer is yes, then just put these equations or reaction to anode. When the answer is no, just oxidize the ion minus.
All right. So this is like diagram flow, right? That taught us
Mm.
if a
This
specific.
is
Yeah,
fun.
that is such in the SOP or the standard operation procedure for the for or the guide for us to arrange the reaction in electrolysis.
I see. I
In
see.
the water, like this.
What do you
Not.
mean?
Sorry. What I mean is this is a reaction cell is in the water or something like because you have.
Well, I
to
mean,
the
it applies universally.
Wait,
oh it
really?
It applies for
really
universally.
I mean,
big
what if
Yeah,
it is, like oil instead of water?
like where's
Or
the 2HO come from?
yeah. I mean, we're gonna take a look at the example afterwards. So
I
Okay,
don't
see.
okay.
worry about it.
Actually, I'm curious about it.
So now, when we
Reduction.
already explain about the oxidation, now we explain about reductions. So
Mm-hmm.
uh, when I say karet, so cathode is always reduction.
Mm-hmm.
Just remember about it.
Yeah,
That's
correct.
not
Okay.
really difficult
Karet,
to
karet,
recall. Yeah, karet.
karet.
Bukan pasal karet. So take a look at the ion plus. Um,
One
you see
is
that when you already took a look at ion plus, and there is a question for you: is the solution or melt kind of a group, either 1A, 2A, aluminum, or mangan? If the answer is yes, hence there is a question again: is that melt or solutions? If it is melt, then just reduce the ion plus. If the answer is solutions, just put this kind of equations for the reductions. Now,
okay.
or the cathode, right? Now, if the answer is no from this point, there's a derivative equations. Is that ion H plus? If the answer is no, just reduce the ion plus. If the answer is yes, just put these equations into that reduction. Now we can try the example first.
Oh my god. All right,
Oh,
let's
what, what,
go.
what, what? Oh my God. I
So
let me finish
there's
it
the
quickly,
exercise
man.
here. So you see, the exercise tells you that you need to write down the electrolysis reactions. So now there is the solutions and the electrode here.
So this is the anode. So we check the platinum because it's platinum. Then
Yeah, the electrode is platinum or PT, and the solution is, what is that trend? How can you read it?
so
It is.
anode should be platinum.
Huh?
The anode should be platinum, right? Hey, sorry, it's not.
Uh,
No, 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 no. Yeah, yeah. I'm sorry.
now
Yeah, yeah.
the
The
answer is
true.
that
Cuprum
Yeah,
sulfat,
yeah.
isn't
the,
it?
the
Cuprum
anode is
sulfat.
The
the anode
cuprum.
depends on the reaction that we already saw just now.
Yeah, yeah. The electrode is platinum. The anode should be the cuprum, right?
The
Am I right?
anode is actually yes, the cuprum, yes.
The
Is
cathode
But
should be.
we may actually the see the reaction here, like, it is the, yeah, copper sulfate,
Mhm.
and the electrode we have right now is
It's
platinum.
platinum, right?
So
So we.
okay, we just take a look at the
diagram
diagram.
flow.
So
Okay.
Yeah, the
we see that
electrical.
we need what solutions,
Oh yeah, so it is platinum.
and
So
the electrode
we have
PT.
to take a look at the ion.
Mhm. Yeah, the most important information is the solution. It is a solution, and then it is called cuprum sulfur oxide, and then the lastly you see the electrode is platinum. Got it.
Yeah, yeah, you are right. And
So
now, um,
the
actually, yes, yes. I mean, in electrolysis, you see that the yeah, the anode and cathode have different reactions,
mm,
but the electrodes is the same. I mean, both of them may be platinum,
mm.
but uh, the reaction in cathode is different with the anode. And now we are gonna take a look at it. So let's see that you have solutions cuprum sulfate and the electrode PT. So electrode is what, PT, right?
Yeah,
So
it's
Yeah,
when it comes
platinum.
to PT,
platinum.
just answer yes. When
Yes.
you answer yes, take a look at the ion. So we see that we have cuprum sulfate. Now when we try to separate, now we got
SO
here.
minus 2.
Oh, I am wrong. Actually, it's sulfate oxide.
Sulfite
Yeah,
oxide.
so
No, no, not sulfite. Oxide. Oh, alright,
Eh?
alright.
Is it not?
Wait. Let me Google it. CuSO4. Oh no, sulfat, man. It is sulfat, not oxide.
Sulfate, right?
Yeah,
Oh, yeah,
sulfat.
yeah, sulfate. All right, good.
Yeah, and we know that
Yeah.
the sulfate is is from the uh, uh, sulfuric acid or
Mm.
asam sulfat in Indonesian. So it is the residual oxidizing acid. So yeah, just put the reactions it is into the our equations
Oh,
in
so you're going to kind of um
no, sorry,
yeah, going to doing operation with 2H2O, 2
yeah,
oh yeah, I
yeah,
see.
Good.
just click credit
Oh, I see.
to H2O and what I
Uh,
don't remember about it actually.
H O2
Again,
plus 4 H
plus,
plus plus
plus.
E. Interesting.
so this case is for um acidic matter, right? Acidic
Huh?
material.
O2,
Yeah, this is not residual oxidizing acid.
Oh,
sulfate,
so you mean this isn't
NO4.
okay. Just continue. The anode is to H2O and the cathode will be oh
The cathode is in different diagram. I mean, it's for green diagram.
so it is
So when we want to determine the anode reaction, just take a look at this diagram or blue diagram. But when it comes to cathode, just take a look at that green. And when you follow the equation, then yeah, you may find the problem's answers.
Okay,
Like
what
let's
is
say
it?
like
let me
this
guess.
is the solution or melt group 1A, 2A, Al, Mn. So you see that we have
Cuprum.
cuprum here, CuSO4.
So cuprum is um
Cuprum is what?
let me take a look.
Like wait, we take a look at the here diagram of the periodic table here. Is cuprum. So it's 1B.
Oh,
It's 1B,
1B.
not uh 1A or 2A or aluminum or mangan. So
So
that
no,
answer is no. Yes. Is it iron plus, H plus, H plus?
No.
No. So
no.
we need to reduce the that's cuprum. All right. So you need to reduce here. As I already told you about reduction, right? Reduction.
Mhm.
Okay. So when we need to
So
reduce
Cu equals to
and what?
uh should be. Oh,
Like
okay,
this,
got
right?
it. So CSJ like that. All right.
All right.
Cu
So don't
plus
forget to
plus.
put minus here.
Oh, just like that. So we
Yeah,
kind of
just like that. I
what
mean,
if
so
it is
just huh?
what if it is 3 plus instead of 2 plus
Uh,
in Cu?
so
Two CO2 plus.
Let's say a certain chemical element, maybe I
okay.
don't know,
Well,
that has 3 plus ion, and then
uh, because I mean, when you see that, well, there is such a there is several ways to determine the plus ion plus of that substance. But I saw from this, so let's say that there there is CuSO4, and you see that SO4 is almost always SO4 2 minus because I always remember SO4 is SO4 comes from uh, H2SO4 or sulfuric acid.
alright, I mean Andrea, like no matter what is the positive ion, maybe 5 plus or 10 plus or maybe 1 plus, at the end of the day the chemical reaction would make it without any ion in the end, like in this case
Oh,
Cu
yeah, yeah, yeah.
plus will be just Cu. Is that like that, Andrea?
Oh, yeah, yeah. I mean,
I mean
in cathode,
Cu is basically plus one or not? No, no, not plus one.
Oh,
That's just when you said
no,
the
no, no.
iron
Yeah, it's not ion anymore.
anymore.
So you see, Aulia, when it comes to ion, that the substance isn't stable, right?
Ah, that's right.
So
That's right.
and
And now
so
it's
it
becoming
will
stable.
absorb the electron here to become cuprum. So cuprum here is more stable.
Yeah, I get it. I get it.
Hmm.
I finally get it. And then we do
And in
the
cathode,
chemical.
we produce electron, man.
Ah, that's
And
right.
it is said as the what is that? It is oxidation.
Yeah, oxidation. And we are going to do elimination to this equation.
Yeah, we are gonna do eliminations. So
We
now
are
we
going
should
to do.
try
Yeah.
to multiply it.
Mhm.
All right, so we see that
Will be
now
two.
it is,
It will
yeah,
be
and we need to put it
two there.
to, yes,
And
and just
so you can
arrange it.
just put it down. Everything. I see. I see. So far, not that complicated yet. Not complicated yet.
Yeah, I just reviewed it just several hours ago.
I mean,
Mm.
kind of curious, Andra Rendia, in Cikarang, are there many superstar students from superstar universities, like maybe from ITB or maybe from ITS in Cikarang that works like this? Are there many workers from that graduate from these universities?
I don't know. Actually, one of the best chemists that I know is from Unpad, I guess. I mean, it's not the best
You mean
because
Ranin?
yeah, yeah, the rank one in our class.
Oh, so Randy,
Uh,
I'm wondering, i- in what class Ranin actually works for?
it's still in chemistry, of course, but I don't know exactly the company it is. But
Oh,
yeah,
so
it's,
okay, it looks like you are no longer to talk about it
I
with.
don't I don't really contact anyone actually. But yeah,
Now we
yeah, but
end
That's
our
all about
our
yes, that's
session,
good.
oh god,
What is this?
So you see that
it's
instead of
potassium
solutions, it is melt.
and
Do you know melt?
iodine. Yeah, it doesn't have water in it.
Oh, that's right. No water. No water. Do you know
No
British?
water.
What British?
Yeah, because accent of water.
Wow, wow.
Yeah, there are no
So
water. It's just a.
my question refers to battery. Is your battery contains solution or melt?
I think it is
It's melt
melt.
probably.
I don't know. It is the iron, right? I don't know. The iron
Yeah,
doesn't melt.
lithium doesn't work well with water.
Yeah, I mean, I've ever heard that when it comes to lelehan, the electricity will work better when we compare to solution because the what is kepadatan, man, the
Density.
Solidity.
fluidity is more solid, so yeah, the electrical transfer should be better
Oh, I
I
see.
see.
better transfer, yeah.
More solid.
That's why when
More.
you try to leak your own battery, it is such high viscosity liquid.
High
Hmm.
viscosity. I see. I see.
And we see that we have, please remember, key I melt or potassium iodine melt and electro C. All right, so
Got it. So we take a look with anode first, then key I means key plus and I negative, something like that. And then the electrode is C, so A definitely going to C yes, and the ion E means the iodine.
so then
And
what is the first step?
take a look electrode is carbon. So yes,
Take a look
take a
at the
look of
ion
ion is
and
iodine and it is not oxidizing. So next, so we're gonna
Wait,
be
it
quick
didn't.
here.
Yeah, it didn't oxidizing that side. So
Uh,
no, I
is
guess
the
so.
ion of no, and then
So
the I itself will be oxidized.
oh,
Good.
that's right.
So what is the answer?
So
No, the
E
ion negative will be oxidized.
and it
The
will
no
be
no.
it won't be ionized. It won't be
Mm,
ion again.
Yeah, it's
yeah.
correct. All right. So now we see at the reaction at cathode.
Okay. Cathode
Remember, it's
was
Ke
K.
melt and electrode.
So
Electrode.
kalium or potassium is actually from group 1A, right? And then then it is
Plus one.
yes.
So
Uh,
yes, the answer is
yes. Then
yes.
you pick between melt or solution is melt,
Uh,
and the
so
ion plus
both
will be
of them
reduced.
will become an element. What is it?
Hmm.
A solid element. Will won't be an ion anymore.
Hmm. So to answer that, I don't know. Maybe it will be the anode will be I plus E, I guess. What is K I? So okay, so I will be
Plus
uh
one. Plus
I
one.
plus one.
Ion
Ah,
minus isodized. So what is the ion minus? Which one? From Ki?
E, the iodine plus
maybe
one
minus.
E, I guess.
I kind of forget actually.
Ion
Plus.
plus.
Uh,
Ion plus one E, like ion plus, like ion
Ionium.
one plus electron, like the oxidation number one just E negative. Yeah, like something like yeah, that's true. That's true. Yeah,
Oh, plus one. Yeah, that's right.
yeah. One equals to.
Wait.
Does
Wait.
it work like that?
Well,
Am I
remember
wrong?
that actually it's
Wait.
oxidation.
Why is what is E
So
again?
I mean
Oh, oxidized. So
it
you
should
want to
be like that.
E.
should
I
should
can.
it be like that?
I mean it should be not like that. I mean it's like
Okay, okay. I was
E
wrong.
is the neutral first without ion. Like it's I
Hmm.
and then
Oh, actually, it
it's
equals to
Oh,
I.
plus.
iodine.
Got it.
Oh, so remember guys, there's diatomic gas. Remember that in
Mm-hmm.
group 7A, like fluor, chlor, brom, and iodines.
Mm-hmm.
You know, uh, all of the substance should have the couple.
Oh yeah, F2, C2, Cl2,
Yeah,
the chlorine.
because you see that. Remember
Stable.
that
Stable.
they have the 7 electrons.
Oh yeah, yeah, yeah.
One, two, three, 4, 5, 6, 7, right?
And then we combine it together.
So this F wants the one more electron to complete the idealism
Stable element.
stable element. Right? That's right. All right, so it should be like this.
All right.
Oh yeah, yeah, yeah. I remember.
So in total, it is eight. It is 8 electrons.
Oh,
So yeah, it should be F. Yeah.
so in this case, it is the iodine.
In real life, yeah, the gas of the group 7 is always diatomic.
Hmm.
So yeah, you need to answer like this.
All right. How about the cathode? So
Uh,
the K will be
and
minus here.
like this.
Oh,
Qi plus 2e. Hmm.
so the
I mean, okay, go on.
the
Sorry.
cathode will be minus in this case.
Sorry. I mean, there is a mistake, man. I forgot. There is a mistake. So you see that yeah, it's kind of tricky. You see that the Ki is mixture of K plus and ion
Minus.
minus. So you see that because the ion minus should be oxidized, so naturally it's already minus from the beginning. All right,
Yeah.
and because it's diatomic, just put 2 here. All right, so when you wanted to increase the oxidation number from it, all right, you need to write like this.
2i negative
Plus
I2.
2A.
Yeah,
And then on the cathode, it will be K plus A plus.
and because of karet, cathode should be reduced, and what would look
Reduce.
like?
K plus.
Yeah, K plus since it's plus one, right? So
Plus
it
A.
equals
Plus A.
plus E.
Oh yeah, plus E. Kind of. Why there has A? Is A is A?
Wait. It's why they are okay. It's just okay.
Oh,
Actually, there are now two, right?
so you already
Add two.
yeah. So
Yeah,
you
because it is diatomic, so you need to put 2
wait. Is it
on that.
Wait.
diatomic?
I don't think kalium is the atomic.
Diatomic.
Oh, kalium. Kalium is
Already,
actually
yeah. Andra is the chemist here.
Oh yeah, I forgot. I got there. Okay, I mean, I guess that's true. It's going to be balanced, right? Uh, but is it true though?
all right. So because yeah, kalium is actually in what
1A, right? Group 1A.
key, right?
Oh yeah, in
So
Yeah, group
you see
1A.
that
Mhm.
if I'm not mistaken, the noble,
Noble.
yeah, the noble,
noble
the
gas.
noble. I mean, the most ideal stable substance should reach the electron number
Mhm.
of either 2 or 8, like potassium. You see, it has 1 electron only, right? Since it's
Hmm.
group 1A. So it should be like this to create the stabilization.
Oh, I see.
Oh.
So both of them in the key, well, I mean, it's kind of the first key and the second key. I will name it as the first key and the second key. So in first key perceptions, well, I feel good
I feel good.
because yeah, I have 2 electrons and it's already good because I already had 2 electrons too. So yeah, both of them are incorporations.
Hmm.
So in the end, it will be K2.
They do.
Yeah, it should be.
Okay.
Well, actually, it's
What is it?
What happened to your mic, Andra?
yeah, I mean, it's because this is cheap mic, so yeah, it's like
Cheap mic.
the phone sometimes release.
Oh, I see. All right,
Hmm.
let's continue.
All right, so
So it's
uh,
just K or 2K
it should be 2K.
Wait,
Hmm.
2K? Oh
or
Yeah,
yeah.
K2.
not K2.
Okay, it's 2K.
Well, I forgot about the rule, but yeah, this is the from nature.
Hmm.
But from the atomic, it should be I2, I2,
Oh, I too. I see.
I2. Yeah, I2. Yeah, so you see that the anode is 2 iod minus, and it turns to be diatomic E2 plus 2E. So 2E here is the compensations of the oxidation number because here the oxidation number is what?
Hmm.
2, here
It's two.
0. So it should, yeah, it should be added by -2 to compensate the this natural oxidation number.
Hmm.
And here is already stable because 2 plus 2e is 0. So both of the side is are already in the natural. Hence, we may arrange that the total of the cell reaction is two
Got it.
minus
2
two
minus
iodine.
2k
2
plus
minus
2k plus
equals to
E2
E2
and
plus
2k.
2K. Hmm.
Yeah, that's right. It's already true. So next, we
Oh
have this.
shit.
Look,
Okay,
sorry. Look at the time. It's almost 3 p.m. Can you?
can we
All
wrap
right.
it
Yeah,
up
yeah.
early?
All right. Is there anything
No, no,
Yeah,
it's
that?
already. Yeah, there are several questions, but I mean, it's already
Yeah.
enough for you. At least you know
Yeah, I know the
the lights,
how
the
to
lights,
implement the idea
the
the idea,
implementations, yeah, or the idea of the
electrolysis
electrolysis
solution.
cell works.
but it is interesting though. With
And
oh
please
Ah,
for
god,
our
oh my god.
and don't
Yeah.
forget to put your own preference.
ah. You
All right.
know, you cannot do this in ISN, because it
Yeah,
means
that's right.
you
Oh,
are
ISN. Okay. So, do you mean that ISN cannot vote?
no,
No,
in
no.
in in the picture they cannot pose
Yes,
like
true.
this, or like this.
Like
They cannot.
this, like this.
But
They're gonna.
But does the ISN personnel have the right to vote?
yeah, they still
Yeah,
have,
that's
of course, but that cannot vote, something that kind of
well.
preferencing to other
Oh, okay. So,
candidates.
all right.
Mm,
So, what I understand that yeah, they're not allowed to campaign any candidate.
that's true.
Yeah,
Yeah, at least in the
it's different
photo.
from the common people.
Yeah, but they can do
But
But
this or
but
do
I
this.
remember when it comes to new order or order baru,
yeah,
ISN should vote the Golkar, man.
Oh,
yeah, that's
It's
that's
all.
kind of
all.
a curang.
That's all problem.
Mm.
All right.
Yeah.
Okay, I found.
Hey,
Well,
when
to
will the
summarize.
oh yeah, what, summarize.
Okay, before we going to delve into political side, I want to summarize. Like this time, Andrea tell us about electrolysis cell. To be fair, so electrolysis cell is to be in short, uh, it's a chemical reaction where we convert electrical energy into chemical energy basically, and in that it transform there are chemical reaction down with it. So it's actually it has some useful properties. For example, uh, you can use it to make steel from from rusty steel to stainless steel. So there are no rust anymore, or maybe you can generate oxygen or hydrogen basically to separate between two from water to hydrogen or oxygen. That's one of the useful properties of electrolysis. And then Andra shows how to derive the chemical reaction in electrolysis by using diagrams. The diagram shows what happens in anode and what happens in cathode, basically. And so far, we pleased to learn that. I think this is informative. This is very informative for both of us who is not a chemical background there. So I think that's all of it, I guess. And
I'm gonna add some a little bit of the course because I would like to make some clarifications about my mistake just now. Yeah,
sure. Mhm.
yeah, sorry. In this case, I'm gonna slideshow for it. All right, so you cannot see the slideshow.
Wait, I'm rolling. Oh yeah.
Just a little bit more about it.
Oh, so you mean there is
like this. That's yeah. There's a mistake. Like you see that in the beginning, uh,
Mhm.
we have what from the anode perspective, we should oxidize the eye, right?
Mm.
So the eye should be oxidized from here to
Yeah, I2 and
here.
2A, 2I.
Yeah, but
Wait,
from cathode it should be
2E,
reduced.
2E.
And
Mhm.
well, I mean that the key the key here
Plus E,
should not be added as two key first, because naturally key already key plus.
E equal to K.
Yeah, so that's what I mean. So in
And
order
then
to uh, equalize between them, we need to times two.
Yeah,
eliminate
times
it.
two.
And then
That's
we eliminate it. I see.
mm-mm.
Yeah.
Yeah, yeah, something like that.
Oh,
Yeah, just a little bit about so yeah, we need to put the natural reaction first, and yeah, just multiply it by the number that should
what
be
is
equal.
that sound?
It's Asar
Oh, Asar.
R. But yeah, yeah, that's a good correction. Thank you, Andra.
Yeah, but
So
for the iodine is the the default should be diatomic,
Diatomic, I
but
see.
for the kalium
it's not
is
that.
not. Yeah, or potassium is not.
I see.
All right.
That's great, Andra. Nice correction.
Thank you, Andra. Actually, this has been a, this is a great this is a great conversation lecture for you.
Then yeah, we'll be like, oh shit.
Oh shit, I almost forgot. But it is nice. So yeah, I think that's enough for us in the podcast. We're gonna see in next Sunday. So next Sunday will be me, right? I'm
Yeah,
going to
yeah.
show
It will
maybe.
be you.
Yeah. So in the end, has this so this is the last week before the first year anniversary. I don't want to recap because we don't have time, but it's been nice to see you guys this whole year, I guess.
Yeah, this whole year.
Yeah, this whole year. So uh, thank you, actually. I guess.
Me too, me
Uh,
too.
yeah. Next week, I'm going to show you something cool. But that's next week. I'm going to make it a surprise, basically. I think that's enough for today podcast. We're going to see you guys in the next week, and thank you for joining us in this podcast. And this whole year, I guess. Yeah, so that's it for us, for me, for us, I guess. Anything to add, Adil?
No, I guess that's all.
Yeah. Yeah, I think that's it. So see you next time. See you next week.